All right, let's see how this goes. Algebra half. Lesson 14, page 51 is all about fractions. Do you know the definition of fraction, you think? You say, of course I do, Mr. Otto, but when you really think about it, can you write a definition without just reading it from page 51? A fraction is not a whole number. It represents part of a whole, right? It's never as much as a whole, it's only part. And a true fraction is between 0 and 1 on a number line. So a fraction represents part of a whole. Why don't you put that into your math line paper under lesson 14, right? Fraction is part of a whole. Feel free to pause the video to get that in there. Next, not a bad thing to include in your notes is what's called the denominator-numerator rule. To be able to do this, we need to know what is a denominator, what is a numerator. Hopefully you've all learned that by now. A great example fraction, the simplest of all, 1/2. If you want to play with fractions, by the way, I snagged Miss C's old pizza fractions box game and put it over by the board games. You can mess around with that, just don't get hungry. But 1/2, right? What's the numerator? If I circle it in yellow, it's the top number. It designates how many. And the bottom number, in orange, we'll call the denominator. It's the total possible. So the numerator is really number we're talking about. Maybe it's the shaded amount or the number that's been referred to. Okay? So the denominator-numerator rule will be basically telling us you can multiply the top and bottom, denominator and numerator, or divide, and you won't change the value of the fraction. The key, though, is that you multiply by the same number, top and bottom. Let's use 1/4 this time, right? If I want to multiply the top by, let's say, 3, it's going to equal the same thing. You say, Mr. Otto, that's crazy. Now it's 3, and I know 1 and 3 are different. The key is that you change the bottom 2. And what do we get on the bottom? Multiplying, I get 12. A couple things with that. Number one, why does this not change the value of 1/4? What I did can be proven as, well, not changing the original number at all. What is this factor worth? Anything over itself is worth 1. Remember that? Therefore, I'm not changing anything, because anything times 1 stays the same. This is equal to this. Now, the other thing I want to mention is you probably see this and think, nails on a chalkboard, alert, this just feels wrong. I'm going to get marked off. Half, why? It's what we call not in lowest terms. It's not reduced. This is actually an expanded version of 1/4, but that is something we want to be able to do in this lesson too. Okay, so the rule was that I can multiply top and bottom by the same number, right? It can't be 3/4, that'll change it. Just 3/3 or 4/4, any number over itself. And we won't change the value. The symbols will look different, but this is still worth the same as it was before. We could show the same thing the way the book does in page 52. It shades a pi 2/5. And then it says, if I cut the pi up into 15ths, all I need to do is color in 6 of those, and it's worth the same amount. If you look at my picture from the internet, boy, the blue looks to end up being the same. It's just cut up more, right? It's got more pieces, but it's still the total amount the same. Think about that for a moment. These are equal. How would I reduce down to get to 2/5? We need to be able to reduce. I can also divide top and bottom as long as what? As long as it's by the same number. Oh, so divide by 3, and we get 2/5. 6 divided by 3 is 2. 15 divided by 3 is 5. Denominator, numerator rule. If the book asked us to actually, instead of reduce a number down to lowest terms, what if we want to expand, let's say, 3/5, a good fraction, part of a whole, to have a denominator of 20? Okay, write out your work. These are good work problems. Please show it. You've got plenty of room. We need to get so that the answer, just set it up, has a denominator, bottom number of 20. We don't know what this is yet, but we know we need to get there. How can I get there? Using the denominator-numerator rule. Am I going to be dividing or multiplying? I did division here, did multiplication up here. We're going to multiply because we need to get 5 to become 20. This we don't know yet. So, top and bottom need to be equal. We're going to multiply by something that ultimately is really only worth 1. Now, what is that going to be? 3 times, well, we can't do that, but let's go through the bottom. 5 times what? Missing number problem is 20. I hope you got it by now. 4. Top and bottom need to be the same. What's 3 times 4? Yes, it's not in lowest terms. Am I going to need to reduce this for my answer? No! It just asked us to expand. Even if it wants us to expand, the answer should be an expanded form, an expanded fraction. Only when we're reducing or doing a regular problem with a reduced answer, lowest terms expected, do we want to divide this down. Otherwise, you're just going to end up right back where we were. Please don't do that. I will shake my head at you rapidly. Finally, example 14.4, page 53. We're going to use what we just learned, GCF. What's it stand for? I'm not going to tell you. You better know that without my help. How can we use it to reduce a bigger numerator-denominator combo like 16 over 32, huh? How do you think? Maybe you've already looked ahead. Well, we need to find the GCF. And what is it? For 16 and 32, quick factor trees, okay? And what you'll find is the GCF is going to be 16, using what we learned last lesson. All right? So 16 is the GCF. We have the fraction 16 over 32. What do you do with that? You divide by the greatest common factor. Divide by the 16. What do we get top and bottom? 2 under 1. Half is our answer. And that's shown on page 53. Pick one from the top and letter F from D through F. So pick 1 A through C and do F as well. Okay? Best of luck. Hope you followed along. Don't be afraid to ask questions.